So this was on the time dilation equation. I'm going to be going from memory, and I really don't have these equations completely memorized. If I do make a mistake, give me a holler. Oh, we have to have my favorite student. Good old, oh, wrong color, Mr. Duick. Have to mark things in red. Come on, eraser. There we go. Good old Anne. Cirque. How much time will pass on the Earth? So I think here, they want me to find t. T0 is 8. V is 99% of the speed of light. So I think I'm going to go like this. T equals T0 divided by the square root of 1 minus V over C all squared. It's going to be 8 divided by the square root of 1 minus 0.99 C over C all squared. Do you see? Do you see? I do see. Let's see what we get. And we found yesterday that unless we're going really fast, this time dilation isn't that noticeable. That's why, Elliot, in my examples, I'm having us go like 95% the speed of light or 99% the speed of light. 1 minus 0.99 squared. Well, if you wanted to type this in one fell swoop, because some of you have asked me, I guess you could go 8 divided by the square root of bracket 1 minus 0.99 squared close bracket. Do you get 56.7? Is that right? So it can be done in one fell swoop, and some of you have better calculators with nicer displays than what I've got up here. What did I say it was? 56.7 years. 2 marks for that. Otherwise, I would give you 1 mark for the equation, half mark for the numbers, and a half mark for the answer, as per usual. A spaceship travels at 96% of the speed of light for 12 years ship time. How much time will pass on Earth? I'm going to take a risk and see if I can do this without listing my data. It's going to be t that we want. 1 minus v over c all squared. So it's going to be 12 divided by the square root of 1 minus 0.96c over c all squared. Geo, do you see? Do you see? Yes, I see. Do you get 12 divided by square root bracket 1 minus 0.96 squared? Do you get 42 point, technically 9, I guess? Yeah, if I round off properly. 42.9 years. I would, again, I didn't say what to round off to. If you said 43 years, I'd take that. 42.86, I'd take that. If you said 42.8, I'd frown and I'd take a half mark off. 1 mark, half mark, half mark. Now they want me to find time on the spaceship. Now they want me to find time 0, which means now the equation is time 0 equals time back on Earth times 1 minus v over c all squared. It's going to be time back on Earth 16. Come on, there we go. Times the square root of 1 minus 0.99c over c all squared. Do you see? Do you see? Do you see? 16 times the square root of 1 bracket 1 minus 0.99 squared. Do you get 2.26? 2.3? I'll go 2.26. 2.3 is fine. What if we were going at 99.5% of the speed of light? It's gone from the Earth for 15 Earth years. How much time has passed? Again, this wants me to find T0. Oh, same marking scheme as before, by the way. 1 mark for the equation, half mark for the numbers, half mark for the answers. Wants me to find T0. Time on board the spaceship is going to be the square... Oh, not yet, Mr. Duick. t times the square root of 1 minus v over c all squared. It's going to be 15 years times the square root of 1 minus 0.995 c over c all squared. Although 15 years go by on Earth, uh, 1.5 years? Again, 1 mark, half mark, turn the page. Three marks. Why 3 marks? Well, you're solving for v. Although, no, wait a minute. I think I'd let you write v, the equation. Oh, I'm going to try and do this in my head. Let's see if I can. I know the time dilation equation is t0 all over the square root of 1 minus v over c all squared. Okay, so it's going to be multiply that, divide by that, squared. Boy. You get v equals c. And is it the t0 on top and the t on the bottom all squared? Yeah. Okay. Anyways, I probably somewhere would have written v equals question mark. And this is also just tricky to type. So I'm going to leave the c as a c for now. That's going to give me this answer as a percentage. Then I'll multiply by the value of c, since this question didn't specifically say, and I'll give you full marks for either answer that you give me. For now, it's going to be the square root of 1 minus t0, 8 years, 100 years back on Earth squared. So the square root of bracket 1, you know what, I'm going to go like this. 8 divided by 100 squared. 1 minus that answer, square root. Do you get 0.9968? Okay, so the first thing I'm going to say is v equals 0.9968 c, or 99.68% of the speed of light. And if you said that, you got 3 out of 3. Or if you went to meters per second, because the question didn't say, you would multiply that by meters per second, by the speed of light, and you would get 2.99 times 10 to the 8th. Wow, that's pretty fast. I would take that and give you 3 marks as well. So for this one, it's going to be 1 mark, and then 1 mark for either of those. I'll even live with it if you left it as 0.9968c and didn't change the 0.9968 to a percentage. Although if I asked you to give it to me as a percentage on the test, which I will, then I would want to convert the decimal to a percent. Little Math 8 review, which doesn't hurt. All right, they want me to find v. You know what? I'm not going to redo that equation. I'm just going to copy it. Okay, I got it. V equals c square root of 1 minus t0 over t all squared. It's going to be c square root of 1 minus time on the spaceship, 20 years, time back on Earth, 1,000 years, all squared. 20 divided by 1,000 squared. 1 minus that. Square root of that. I get 0.999. You know what? I think it's going to be 3 9s, and I think I'll round off there to an 8. The reason I don't round off here, by the way, is if I round off here, it's going to be 100%, and we're not going 100% at the speed of light. So I kind of keep going until I have the first non-9 digit, and that seems to be where I'm going to stop. So I get this. V equals, how many 9s? 3 9s and an 8. 0.9998c, or 99.98% of c, or if you want it in meters per second, 2.9994 times 10 to the 8th meters per per second. 3 marks for that. 1 mark. 1 mark. 1 mark for the numbers, and then 1 mark for either of those answers. If you could give yourself a lovely score out of 14, please, that would be delightful. Geo, last day I told you that that length contracts. Time slows down when you travel fast. It gets even stranger. Actually, you know what? I think what we should do, because we're kind of becoming little physics nerds here, you can, if you want to, cross out the word stranger and you can replace it with the word cooler. It's really up to you. I think this is cooler. Einstein, and I'm not going to do a proof here, Kiana, but Einstein showed that as objects speed up, there is an increase in mass. And it's governed by this equation, m equals m0 over, m equals m0 over, we can write that Lorentz factor little shortcut trick if we want to, or it's square root of 1 minus v squared over c squared. Where m0 is the original mass at rest, it's rest mass, and m is the mass of the object when it's moving. As you speed up, as an object speeds up, its mass increases. And again, much like time dilation, Sarah, you hardly notice it. You awake? Okay. You hardly notice it when you're not going really, 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 really fast. So let's plug in some numbers. Suppose an object had a mass, get your calculators out please, of 10 kilograms at rest. So that means m0 is 10. And suppose it speeds up. What would its mass be if it was traveling at, now I started pretty quick, Alec, right away, 2.5 times 10 to the 8th. 3 times 10 to the 8th is the speed of light, so 2.5 times 10 to the 8th. We're getting pretty fast. I didn't want to do a whole bunch of examples where there was little or no difference. Remember yesterday we did a bunch where our calculator couldn't even track the difference. We just kept getting a 1 as an answer. So what's it going to look like as an equation? It's going to be m equals m0 all over the square root of 1 minus v over c all squared. m0 is 10. 1 minus, I guess here, since I didn't give you the speed of light as a percentage, we'll have to, Matt, actually put c in as a value. So on the top, there's going to be a 2.5 times 10 to the 8th. And on the bottom, there's going to be a 3 times 10 to the 8th, all squared. This time we don't see. Alrighty. However you type this in, I'm going to start inside the brackets. 2.5 scientific notation button 8 divided by 3 scientific notation button 8 equals, I get 8.3 or 0.83 repeating, squared 1 minus that 0.305 repeating, a square root of that, and then it's 10 divided by that number. And at this speed, this mass that originally weighed 10 kilograms as its rest mass would weigh 18.1 kilograms. What if it was traveling at 98% of the speed of light? Okay. M equals m0. You know what? I have the equation written right here. Let's see if we can go straight to plugging in numbers. Our rest mass is 10 over the square root of 1 minus Do I see this time? Yes, I do, a little nicer. So it's going to be 0.98 C over C squared. Don't forget the squared. I'm going to see if I can type this in one shot. 10 divided by square root bracket 1 minus 0.98 and square the 0.98. So if we're going 98% of the speed of light, this 10 kilogram mass would weigh 50.3, I guess if I round off properly, kilograms. It's already weighing, I got to be careful, not weight, it's mass. It already has a mass 5 times greater than it did before. What if we try going 99% of the speed of light? It's going to be 10 all over the square root of 1 minus 0.99 C over C all squared. You know what, Geo? I have a good calculator. I can just backspace, since I typed it all in one fell swoop, and change the 8 to a 9. And I get 70.9 kilograms. The fastest that we can get things is at the Large Hadron Collider. The Large Hadron Collider can get subatomic particles. It could not do this with a 10 kilogram mass, but it can get subatomic particles to 0.999999991 C. It's 1, 2, 3, 4, 5, 6, 7. It's 8 nines and then a 1. This is only 2.7 meters per second slower than the speed of light. Pretty fast. Okay. What would that 10 kilogram mass weigh now? How many nines? 1, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 8 nines. 1, 2, 3, 4, 5, 6, 8 nines, and then a 1, and then a C, and then a C again. The C cancels. Okay. 10 divided by Mr. Duick. Let's try that again. 10 divided by the square root of bracket 1 minus 0.1, 2, 3, 4, 5, 6, 7, 8 nines, a 1 squared. And Tato, this is one of the reasons that you can't reach the speed of light. What would the mass be if you actually got to the speed of light? It approaches infinity. So basically we say this: to travel at the speed of light, your mass will become infinite, and you need an infinite amount of energy to get an infinite amount of mass to that speed. Light is the cosmic speed limit. You're not foolishly on your phone or anything like that there, Gio, were you? No? Okay. So I got to write this one down. 74535.6. 74535.6 kilograms. Now that's for a 10 kilogram mass, but Kiana, the protons and the neutrons and the things that they're causing to accelerate also have a massive increase in mass, and that's why it takes so much energy to get them going that fast. I think the Large Hadron Collider, to get the protons up to this speed, I think it takes something like about the same amount of energy to power a small town. It takes a lot of energy because their mass is increasing. How would you get, going back to here, what if instead of me asking you to find the moving mass, what if I told you the moving mass and I said find the rest mass? How would you get the m0 by itself? Times the square root over? Okay. How would you get the v by itself? Which equation does this look like? The time equation or the length equation on your green sheet? This looks like the length equation. The length equation is divided by the square root. Look at your green sheet. I don't think it looks, doesn't it look like the time equation? So I think the velocity equation is going to look just like the time velocity equation, but instead of t's, what letter will be put there instead? Let's add that to our green sheet. So on the green sheet, next to the mass equation, you can write v equals c great big square root of 1 minus m0 over m all squared. That would be if I, is that right? I don't, the time equation is the 0 on the top for the time equation? We're using the time equation, not the length equation, because the length equation has the stuff swapped. Okay? Am I right? I'm going from memory. I don't have a green sheet here. Okay, so add that there just in case. I can't remember if I asked you to find the velocity or the speed and gave you two masses, but for what?
MO is the original. And the M is the one when it's moving. Wouldn't you want the one where it's moving on top?
We're going to match the O's just as variables in the equation. Okay? So it is going to be, I think, this one here.
Okay.
I could derive it if we needed to, but it will end up being this.
But he always
I know we're inconsistent in what we're calling original and moving, but I think in terms of the variables, Tato, the equation is a mirror image to the time equation, and so the O would end up in the same place as in the time equation, even though it means something different here. I think algebraically, the algebra would still be the same. Still would be. What's your homework? Folks, I think you can now do every single question on here. This has some time dilation, some length contraction, and some mass increase. You could do this on a separate piece of paper. I will post an answer key showing all my steps online a little bit later. I did attach the answers as well. You can check your answers to see if you're doing it right. No guarantees that I didn't make a typo in my answer key. I made a typo in the last one. Should you find a typo in my answer key, as always, candies are available.